So we're going to look at the introduction to limits. And we just want to get an idea of what exactly is a limit. So we have an example here where we have a police are trying to find a missing person, and it looks like they have some tracking data here, maybe cell phone data that looks like he was started at Lillooet, kind of went this way, went northwest a little bit, kind of headed west, started heading south to Vancouver, and then that's the last known location right about there, maybe somewhere around Squamish. So based on this pattern of movement, where would you think this person is headed? Now, we don't know if they actually got there, but it definitely looks like they're headed towards Vancouver. Okay, so the limit is something that is like this. Now, when we talk about this pattern, it looks like this pattern is going to head to Vancouver. Now, this person may have ended up in Vancouver. We don't know. They may have just like all of a sudden taken a left turn and headed off to somewhere out there. We don't know. But based on the available information, it looks like this is where they're headed. So our best guess, okay, it would be Vancouver. So the limit is like this. It's basically our best guess. We just want to know essentially where does it look like we're headed. Now we don't necessarily know if it's going to get there, but the limit just tells us looks like we're heading towards Vancouver. And this is the idea of the limit. Okay, so in this case, the information or the pattern, let's say, the pattern looks like it is headed towards Vancouver. Okay, do we know for certain that they get there? No, we don't. Okay, and limits don't tell us anything about what's actually happening there. So this is how we kind of should understand limits. It's a formal way to assess what's happening if we're to go where we're not really allowed to go. So in mathematics, this is very important to have because there's some places we're not allowed to go. Okay, so the places that we're not allowed to go are places like holes, asymptotes, discontinuous points, and places where we're going to look at something called instantaneous slope. So we're going to characterize limits in two types. What's happening locally, okay? So this is a situation what's happening locally. It's headed towards some local position. And we're also going to look at limits of endpoint behavior. So what's happening out at infinity, at positive and negative infinity. Okay, so these are two areas that are very useful to do. So again, when we do this in calculus, it's going to be very useful because we're going to analyze really difficult parts of functions, holes, asymptotes, discontinuous points, and instantaneous slopes. Okay, this is going to be really important because we're going to end up dealing with slopes that have essentially no rise and no run.